What's up? Here we are once again talking about cylinder heads. So we've got a head on a stand here. We're going to be talking about a little bit. Cylinder heads. Yeah, they go on top of the cylinder block, but there's a little more to them, right? So there are cast iron heads, which is the OG. Then we've got aluminum heads, which are more prone to warping and cracking, tend to wear out a little more quickly due to dirty oil wearing down the soft material. And you still need iron valve guides and valve seats in them. Valve guides and valve seats we'll get back to in a little bit. So let's talk about cast iron and CGI, compacted graphite iron, which is the latest and greatest, just like our cylinder blocks. So what is in a valve? What is in a cylinder head, and what attaches to a cylinder head? Well, you've got all your valve train components here. So you got your rockers, you've got your camshaft sitting on this back side. You can see back there. If it's an overhead cam design. If it's not an overhead cam, then you naturally will not have a cam in your head. There's also valve guides and seats, like I say. We'll get back to those in a little bit. And both manifolds, intake and exhaust, are going to attach to your cylinder head. So down here, we've got intake ports. Over here, we've still got an exhaust manifold and even a turbocharger mounted on this head. It's also going to contain all kinds of drillings and bores for the injectors, coolant, oil, fuel, air, etc. You can see there's even a bore for the injector wiring harness over here. So all kinds of important stuff in there. The temp sensor, coolant temp sensor, is often going to be in your cylinder head too. Cylinder head is one of the last places that your coolant gets to before it hits your thermostat and cycles back around through your radiator. Therefore, the coolant's going to be about the hottest that it gets in your cylinder head. Naturally, you would want to know the hottest temperature of your coolant, not the coldest, so they put the temp sensor there. So let's get a little more nitty-gritty. We'll talk about different flow designs. We've got 3 different types of cylinder head flow designs. We've got a cross flow, parallel flow, also called uniflow sometimes, and reverse flow. So cross flow is going to be the most standard, just like this one here, where you've got your intake over here and your exhaust over there. So it's cross flowing. It's flowing right across that head, intake on one side, exhaust on the other side. It doesn't matter which is which. Then we have parallel flow. A parallel flow, if you want to know what that looks like, look up an ISM, Cummins, or if you want to look up a gas engine, you can look up a 4-liter Jeep. It's where both your intake and your exhaust manifolds are on the same side. So there would be another set of ports between each one of these for the exhaust. You would have your intake going in and your exhaust coming back out the same side. A cross flow head breathes a little bit better, but a parallel flow has less thermal stress because that intake air is cooling back down the exhaust flow a little bit. It's transferring heat away from those exhaust valves, pulling it back out the intake valves. And then finally, a reverse flow. Reverse flow heads are used in turbocharged V-block diesel engines. If you think of a conventional V8 or V6, you got exhaust manifolds down the side and intake manifold across the whole center. Well, a turbocharged diesel in a V setup is often a reverse flow head where your intake manifolds are on the outside and your exhaust manifolds are on the inside. Why would you want to do that? Well, your turbocharger needs all that exhaust to spool it up. So the shorter path it has, the quicker you'll get it to spool. So if you put those exhaust manifolds right in the valley there, then it can go out just the manifold, the turbo can sit right on it, and you can have instant spool. It also makes a more condensed engine package, which is always good for vehicle manufacturers. The smaller you can make it, the more room they have to move it around. So those are the three different types of flow heads: cross, parallel, and reverse. Next, we'll talk about our intake port design a little bit. You can have a high swirl or a low swirl. And what this refers to is how these valves are laid out in the head. If we're talking about a 4-valve head like you see before you, if these valves are laid in a square manner, then it's a low swirl head or a square valve setup. If it's diagonal, it would be a high flow. And what they do is they kick those valves so that more air is flowing through one, and it's making that air more turbulent, spinning it around as it goes into that cylinder to better atomize the fuel mixture. The more turbulent that air is, the more mixed up everything will be, the more complete your burn will be, the better fuel economy and the better your emissions will be. So next, we've got whether it's a single or a multiple head. This is a single head in front of you. We've got a small single head behind us. And across the shop over there, we've got both a little Mack and an N14, which are multiple cylinder heads. That Mack has 2 cylinder heads, so 3 cylinders per head, and that N14 has 3 cylinder heads for 6 cylinders, so 2 per head. Not to be confused with valve covers. A 12-valve B series Cummins, 6 different valve covers, only 1 cylinder head. So if we have a single piece head, then these days, chances are, we may have an overhead cam. Like I showed you earlier, this has an overhead cam. What it means is the camshaft runs through the head. It's above the head. This engine, or this cylinder head back here, out of a Deere, 4-cylinder, 2 valves per cylinder, no camshaft in there. As a note, this does still have fuel injectors in it. I just laid it flat on the counter. If these were good injectors, they would now not be good injectors. These injectors are already junk, so I can do that. You'll always want to block your cylinder head up with some wood. So, since this is a 2-valve per cylinder, not an overhead cam, so you got holes for push tubes here. What's the perks of an overhead cam or an in-block cam, often called a push tube engine? Well, an overhead cam is going to allow higher injection pressure, have more precise valve timing, and be able to have higher injection pressures because you're not bending push tubes.